we're asked to find the equation of the cosecant function for this graph. Okay, and so one trick is to find the equation of the sine function that goes in between these dots. Sorry, not between these dots, between these blue curves. And if you can figure out the sine function in black there, then cosecant just replaces the sine function in the algebraic term. You know, instead of writing sine, once you get that all written out, you just replace that with cosecant. Okay, so let's find the sine function for that black curve that I just drew. Let's see. So one thing we could start with is the midline. Sine of x, when you don't mess with it, it starts at the origin, goes up to the peak of the amplitude, then goes down to -1, then comes back to the origin, like this. Okay, and it completes that wave in 2 pi units, because that's the period of sine. So sine starts at the midline. We can locate the midline on this graph because it starts at the highest point of the black curve is 2.5. The lowest point is 1.5, so the midline has to be halfway between those two. So the midline is here at 2. Okay, so that means the vertical shift on this function is +2. So whenever we make a graph of sine or cosine, we're thinking about this form. Where we want to figure out the letters A, B, C, and D from the graph. We want to put numbers in for them. And so this helps us find, this is determined by the midline. We just found out that this is 2. Okay? And then the amplitude is something else we can get from that information. The highest point is 2.5, the lowest point is 1.5 on the black curve, because again, we're graphing sine first. So that means the amplitude is 0.5, because the amplitude is the distance from the midline to the top of the sine wave, or the distance to the low from the midline to the lowest point, either one. Okay, so we got sine, so we need a B and we need a C. B is determined by the period. B is determined by how often this thing repeats itself, and we've got 2 dots given to us by the software. It goes between -4 pi over 3 and 8 pi over 3. So that distance between those 2 dots determines the period. And remember, B is not the period. B is a coefficient that helps us determine the period if we were given that. So we got 8 pi over 3, -4 pi over 3. Let's subtract those two to find out how far apart they are, because one of them is negative. Well, either way you want to subtract. So I took 8 pi over 3 and subtracted by -4 pi over 3 to find out this distance, how long it takes until this thing starts repeating itself. So 8 plus 4 is 12. 12 pi over 3, that's 4 pi, right? Okay, so the period is 4 pi. And in this equation, the period is always 2, for sine and cosine, it's 2 pi divided by b. We just figured out the period in this equation is 4 pi. So if we plug that into this mini equation over here, that'll help us find b. Okay, so I got to multiply b to both sides. So I got 4 pi b equals 2 pi. And then I can divide 4 pi from both sides. So I get b is, looks like 1/2. Yeah. So b is 1/2. So we found out what b is. Now the last thing we need is c. So to figure out what c is, we can now plug in a point. Since we have every other letter except for c, we can plug in one of the points they gave us. This is like y equals all this stuff. Sorry, that's a 2 there, not a 1. Okay, so the last thing, like we said, is we need is a c. To figure out what c is, we need this whole equation to equal 3/2 once we've gotten to x equals 8 pi over 3. So we want 3/2 in for y. This is 0.5, that's 1/2. I'm not sure which would be easier. Probably 1/2 to keep fractions. Okay, 8 pi over 3 minus c plus 2. So if I want to solve this equation to figure out what c is going to be, I'm going to subtract 2 from both sides. So I get -1/2 equals 1/2 sine, then all that stuff on the inside. Let's try to get sine by itself. So we want to multiply both sides by 2, so we get negative 1 equals sine of 1/2 8 pi over 3 minus c. Okay, so sine is negative 1 only in one spot, okay? Sine is always the y coordinates in the unit circle. So an angle of 0 degrees is here, right? That's 0, that's 1 comma 0. So sine is 0 for an angle of 0. Sine is 1 for an angle of 90 degrees. Sine is 0 for an angle of 180 degrees because the y coordinate here is 0. Sine is the y coordinates in the unit circle. So we want to get to negative 3 pi over 2 in positive 3 pi over 2 in radians. We need this inside to equal 3 pi over 2. And so in order to make that happen, let's distribute that negative 1/2. So that's 4 pi over 3 minus 1/2 times c. We need to find a value for c to make that equal to 3 pi over 2 on the inside, because sine of 3 pi over 2 would equal negative 1. So what does this have to be? We set up a quick equation. 4 pi over 3 minus 1/2 c equals 3 pi over 2. We can subtract 4 pi over 3 from both sides. So it's going to give us, we need common denominators, so that's 8 over 6, and this would be 9 over 6. So subtract the 8 pi over 6 from both sides, so we get pi over 6. And then we need to multiply that negative 1/2 to both sides, so we get negative pi over 3. So c needs to equal negative pi over 3 in here. And I think that's it. We've got everything. But just to recap what I just did there, we're trying to figure out what c needs to be in order to make this whole inside equal 3 pi over 2. Because sine of 3 pi over 2 would equal negative 1. And we just found out the particular value is negative pi over 3. So for our final answer, almost our final answer, I'm plugging in pi over 3 in for c, and it's a negative pi over 3. That's why I switched that to be a positive. And then the final answer is cosecant, not sine. So you'd say 1/2 cosecant, and then all this other stuff. Because we found out the equation for this black curve. Cosecant is just replacing the word sine with CSC.